Hey guys, so this is the fourth part of the Java programming tutorial. Today we are going to concentrate on user input and how you can do this using the scanner class. And we're also going to look at control structures such as loops and if statements. So a scanner is another example of a class in Java, and using it works in a similar way to what we did with strings, in terms of the dot operator that instantiates a method of the class. However, there are some differences between using strings and using scanners, which we'll come to in a minute. So I've set up a project called Scanners here in the Eclipse IDE, which, as I said in the last few tutorials, I've did this in the first one. So please feel free to go back and look at the first few tutorials if you don't really understand what's going on. So let's create a class here. So let's make sure we're in the right project. So I'm just going to call it user input, because that's what we're going to do. We're going to be creating a class here that will take a sequence of numbers and calculate the sum and average of them. So you may notice the font in Eclipse is a bit bigger now. Having looked through my videos previously, I decided that it would be easier to have a larger font. So as I said, this program is going to read the sequence of numbers, and we're going to determine, say, the sum and the average of the numbers. So nothing too complicated, but it's just going to demonstrate the use of a scanner. Now, the first thing you have to do when you're using scanners, such as many other objects in Java, is you have to import the class. Now, stuff like string and all the math functions that we can get into soon are already imported by default in every Java program. So there's a package called java.lang, and all those classes in that package are already imported. Stuff like scanners and all the data structures that you can use are not. So you have to use an import statement, and this goes above everything in the file. So the import keyword says to the compiler, I want to import a class, and importing a class or a package just, in essence, puts it at the top for you to use it. So the scanner is in java.util. So, and you can see Java, the Eclipse IDE actually comes up with the different things you can use. It's java.util.scanner with a capital S. This will go yellow for now because we're not using it, but as soon as we use it, that warning will go away. So java.util is a package that has many different types of data structures and useful things that you can use. Feel free to check those out in the Java documentation. I put a link to the Java documentation at the bottom of the video. So after you've imported the scanner, we need to go on and put our main method in. So you'll be familiar with this hopefully by now. Okay, so now we have our main method. So first, before we go in any further, I want to talk to you about comments. Now, comments in a program make the program more readable by other people, more maintainable in the future, and even for yourself. Sometimes you go away for a couple of months, come back, and you're not sure what happens in your program. Having comments definitely helps. So in Java, there's three types of comments you can use. The first type of comment is a single line comment, and we do this by placing two forward slashes here. Everything to the end of this line is now a comment. So you see that if we press enter, there is no comment here. So comments in Java, normal comments anyway, are highlighted in green. There's also a multi-line or block comment, and as the name suggests, it's in a block. Now, these are separated by a slash and then a star. And you see when you press enter, it actually auto-completes it for you. So there we go. The third type of comment you can have is what's known as a Java dot comment. Now these relate more to the creation of classes and interfaces. It's dot slash star star for these. And this also works in the same way as the block comments. These ones will come into later on. Note here that there's only one star at the end of this, but 2 stars at the start. We'll come into this in the next couple of tutorials when we'll be defining our own classes. So from now on, I'm going to use comments in the classes I create during the tutorials, and the code that goes up on the Dropbox download link will have these comments in them, and I'm going to do it from now on. So first, what we need to do is we need to go about creating a scanner. Now, creating objects are not as simple as defining the variables. Strings are a certain special type of object that allows you to create it using the equal sign and just putting the constant in it. So earlier on we had, string 1 equals hello, if you remember from the last tutorial. So that works for strings. For scanners and other objects like this, doesn't quite work like this. So it still has to have a type, which is a scanner. Now I'm going to call this input scanner. It's just you notice the variable name conventions from the second tutorial. There's still an equal sign. And this is where it gets different. To instantiate an object, you need to use the new keyword. Now new is assigned to the compiler that you want to create a new version of whatever the object is. So new, as you notice, will come up in purple. It's a keyword. So we've got scanner, input scanner equals new, and after it comes the scanner again. So you're saying that the scanner you want to create, called input scanner, is equal to a new note to compiler to create this object, scanner. Now when you create an object, you make use of what's known as its constructor. Now constructors are something we'll come back into in the next tutorial when we actually go about creating our own. For now, we just need to know that a scanner takes some kind of input stream. Now for the simplicity of this tutorial, we're going to make console input, and console input is system.in. So this will mean that the scanner will now read from the console down here. So when the program starts, you can type numbers into the console, and it will treat this as the input to the program. So after we've created the scanner, we now want to determine how many numbers we're going to let the user input. For this simple first example of a scanner, we're going to say 4 numbers. So let the user type in 4 numbers. Now user input is taken by the scanner, so the scanner is an object. So now you can use it the same way as you use strings, only it's got different methods. So we want to create 4 variables that are numbers, so let's just call them ints for simplicity. So let's go for number 1. Now remember, from the second tutorial you can declare and initialize and assign a value to a variable in one line, so that's what we're going to do here. So int number 1 is going to be the first number that you type in. Now to get the first number you type in, you put input scanner, and it has a method called nextInt. NextInt simply takes the number that it gets from whatever the stream you've put here, which is system.in, and assigns it to that value. Now, scanners have a lot of different next things. So next is a string. You've got next big decimal, big integer, next every kind of primitive type you can get, and string is just next. But for now we're just dealing with integers, so let's go for another one. And these take the same form. A little bit repetitive here, but it's only 4, so we'll be okay. Okay, so then we have our 4 integers. So numbers 1, 2, 3, and 4 are now going to hold the 4 numbers that the user types in. So now we can do things to these numbers. So let's say that the sum of them is just simply the cumulative addition of all of these numbers. So let's add all these numbers together. Excuse the typos. Okay, so that's the sum. And let's put a small comment out there. Okay. Let's do the average as well. Sum divided by the number of numbers. So, and there's 5 at the moment, so let's just divide it by 5. And seeing as we learned earlier on that Java does integer division by default, we now can do a more accurate average. And we're going to do this double. So I'm going to call average for accurate average. And if you remember, to make Java do floating point division, all you need to do is make one of the operands a floating point number, and in this case 5.0 is registered as a double. So that's just got the 3 variables that we need to print out to the screen. Now if you remember in the last tutorial I showed you string formatting using the string dot format operand. There is also another way that you can use string formatting, and it is in the system package. So remember, if you had a normal print statement, you can have print ln, or just print, doesn't put a new line character. There's a printf, which stands for print format, and this works in the exact same way as string format, and it's easier to do than the print ln string dot format and put the format in there, less brackets to deal with. So this also takes the string that's the format specifier. If you don't know what's going on, you can find this in the tutorial before. The previous tutorial shows you how to do this. So let's say that the sum is, and we want %d. We can put sum in here. Now, printf does not put a line terminator at the end. So if I was to do this and put another system.out.printf at the end for the average using integer division, these two would be placed on the same line. Now the escape sequence, which is a series of characters that tells the Java compiler what you want to do with them for a new line character, is /n. So that then tells the compiler to put a new line character at the end of the statement. So when you're using anything other than print ln, you need to put this here, or your output will not be as you expect. And all we need to do is put another printf statement in. The proper average is, and because this is a floating point number, we need f, and let's say we want it to 2 decimal points, so we need 0.2f. And I'll put average in there. So now if we run this, so we can now add in some numbers and see what comes up. So you want to see a blank console. So let's enter, say 5, hit enter to say that's the number I want to enter in. 3, 8, and 4. So now we've got the sum's 20, the average into division is 4, the proper average is 4.00. So that was an example that somehow didn't work out the same as, integer division was actually okay in that case, so let's try and find something else. So let's 3, 9, 14, and 6. There we go. So now you see that 6.4 is the actual average and 6 is the integer division average. So it's usually always better to use floating point division. Nearly always there's some cases where you might want to use normal division. So we have this program now that has 4 numbers. You can enter them, you can get the sum, the average, the proper average, but it's not as useful as it could be. What happens if you'd want to use a variable amount of numbers? You don't have to have 4, you don't have to have 5, and you even don't want to have the same number of numbers through different runs of the program. So we can improve this to use a variable amount of numbers by using a loop. Now, loops are part of a group of control structures, and control structures are commands that control the flow of a program execution. I won't just go through loops at the moment, I'll go through all the basic control structures so that you get an idea for them all. So let's go for this. So I'll open my notepad up here. So we've got different kind of control structures. We've got an if statement, we have a switch statement, there is a while loop, a do while loop, and a for loop. These are the ones I'm going to be going over. Some of these are more useful than others, and I'll get to them when I come through. So if statements are the basic control structures. So if says what happens when this is true, and optionally what happens when something is false. So say somewhere in a program I had a variable called number, and it was equal to 5. Somewhere down the program I could have if. So how about we wanted to check if the number was indeed equal to 5. We can use an if statement to do this. So the main syntax of an if statement is the keyword if. After that, the expression you want to say, you want to test if it's true, has to go inside parentheses. So I can test here if number is equal to 5. Now, the equality sign is different than the assignment statement. It's a double equals. So that means if number is exactly equal to 5. If I just put this, that would give me an error. So, if number is equal to 5, we want to do something. Now, if number is equal to 5 and you wanted to do only one execution, you could just put it in the next line. So you could say system.out.printf or println it's 5. Of course, if you wanted to do more than one line, you'd have to put a block in. And this block could say, let's see, then you could set it equal to 6. Then, I'm not sure why you would do that, but you need to put a block. Now there's an optional case to an if statement, and this optional case says, well, what happens if the number isn't 5? What happens if this if statement turns out to be false? And there's an else keyword. And else is the opposite of the if. So, what happens if the number isn't 5? Well, let's say we just wanted to set the number to 5. Now you may notice I don't actually need the block here. But sometimes it makes it a little more readable, sometimes it confuses the structure of the program. I usually put them in just to keep the brackets there. It's so that if I add an extra line in, I don't have to remember to put the brackets in. Another optional thing in an if statement is to have more than one else kind of, but what happens is, say you wanted to say what happens if the number's 4. There's an else if command, and that's a kind of secondary thing, so we can do else if the number is equal to 4. And we can put something in here, just whatever, just something. And you can do as many else ifs if you want. You can put 5, you can put 6, you can put as many as you want. The else always goes at the bottom. So the next thing we're going to come up against is a switch statement. Now, a switch statement is kind of like this run of if-else if statements, only you use a keyword called case. So first you need to instantiate the switch statement by typing switch, and inside the brackets has to be a primitive type. So you could switch on the value of an integer, so we could switch on the value of number. Now in the new version of the Java development kit, Java 1.7, you can actually put a string in there, but I've never actually used it before, so I'm not going to talk about strings and switch statements because they're just new, so feel free to go and have a try at that if you do have the new version of Java. At the moment I don't have the new version of Java, so I'm not going to be testing that out for just now. And you put a block at the end of this. So inside this block goes a number of case statements. So there's a case keyword, and after the case, you put a space and then whatever it is. So case 5, and a semicolon. So if case is 5, which is the same as this if number is equal to 5, we can do system.out.println. It's 5. Now you can have another case here, case 4. Do something. At the end, you can put default, which is the else. That could be the else. So in here we could put number equals 5. So you see how these kind of relate. Now one thing to be careful about a switch statement is if this case 5 is true, it will execute 5, it will execute 4, and it will execute default. To stop this happening, you need to use what's known as the break keyword. The break is a keyword that breaks out of the innermost loop. So in this case, it will break out of the switch statement. It's always best practice, unless it's very, very necessary to do this, to put break in each one. Break, you don't need to put a break in the default because it always comes at the bottom. So if that gets executed, then nothing else is after it to execute. So this break statement is usually necessary, unless in some case where you want either one at the bottom or many of them to happen, depending on what the case is. Now bearing in mind you can put more than one case for each line, so I could put case 4 colon, case 3 colon, so that will execute when the number is 4 or 3. So the switch statement is quite flexible, and if there's a lot of cases where you need to have multiples, like this case 4 and 3, it might be better to use in the if else statement, but usually, in my opinion, the if else is the better option to go for. So the next thing we can do is a while loop, and a while loop is a condition, a stopping condition that says do this piece of code inside this block until this condition's met. So the while keyword, and yet again, put it in brackets. Now remember, this is a stopping condition, so if you want number equal to 5 when it stops, you need to do while number is not equal to 5. Otherwise, you will get the wrong execution, and the block with the curly braces is needed as well. So inside this block is the code that is executed every time until the number is equal to 5. Now you need to be careful with these, because if you don't alter number and it's not equal to 5, this could happen forever. So for simple cases, I can just increment number. And that will increment number every time it goes round until number is equal to 5. So the while loop is quite a simple thing to do. Do whiles are different. Do while loops are similar to the while loop, only the condition is tested at the end. So what that means is that the condition, the executed code is always performed once. There are not many cases that I've found personally in my programming experience where do whiles have been very useful. But I'm sure there are plenty of applications that could be suited to a do while loop. So basically you have a do keyword, and the block goes after this. And you can do this the same, you could do number plus plus. And out here, put the while number not equal to 5. So that's how you do the do while loop. You can see the problem with this. If number was equal to, say, 5 already, then it would be incremented before it was tested, which is most of the time not very good. So I mean, if you think of anything to do with a do while loop, feel free to use it. I've never actually used it properly when I've been programming. The last loop is a more complicated one, although it's used similarly to the while loop. The for loop. Now the for loop has a for keyword, and the conditions also go inside the brackets. This time though, there's not one thing to write in the brackets, there is 3. So the first thing is an initialization variable. Now I could say int count equals 0 in here. and that goes after a semicolon. The second argument to the for loop is the stopping condition. So I could say, well, count is not equal to, or well, count is less than 10. And the third thing is what happens every loop. So the variable count could be incremented by 1. So you can see this loop will actually go around 10 times, from 0, 1, 2, 3, all the way up to 10. And this, you could even put number plus plus in here. That's not very useful with a for loop, but it demonstrates the syntax and how you use it. Now note that any one of these conditions in the for statement can be left out. You can leave them out. For instance, the very simple example is a for loop that has 2 semicolons in it, and that's empty. 3 empty blocks. That is actually an infinite loop. We can put a block after there, so that will run infinitely. I mean, unless inside this block, somewhere along the code you had break or something like that, that would work. So now you've seen all the kind of control structures that you can use. Let's now put these into use here. So to allow our program to accept dynamic input from the user, we can use a while loop with an appropriate stopping condition instead of just having 4 variables. For this, we have to alter this program. Now, to do this, what I'm going to do is I'm not going to alter the actual program. I'm going to create a new class, and I'm going to call it user input improved. And what I'm actually going to do is I'm just going to copy this all through. Let's get rid of this just now. Now, bearing in mind that now that I've copied this, I have to change the name back to user input improved, so that it matches up to the name of the file. It's just so that I can put this up and not deface this program. So the import statement is still the same. You still need to import the scanner. You still have the public class and the main method. You still have your scanner. The only thing now we need to do is we need to set up a couple of variables here, so that we can keep track of the sum of the numbers and the number of numbers that are being inputted. So let's create a couple of variables called sum and count. Put a helpful comment up here. Count is the number of numbers that have been inputted. Now these 4 numbers we can get rid of. And in fact, all this down here we can get rid of as well. So let's just get rid of this. Put the block back in. That's a mistake. So now we can use a while loop here to test whether the scanner has any more. Now what we're going to do is we're going to say we want the program to keep running until it has run out of things to do, or the user types -1. Now when it runs out of things to do is when the user presses Control Z in the console, which is the button to signify the end of input. So we can do while, and it's input scanner. Now to test if it has a next, we just say has next, and that method tests whether the scanner has anything else to read. This will stall until something else is printed out if there is nothing in the console. So while the input scanner has next, we need to now create a number variable. So let's just call it number, and it's the same as last time. Input scanner.nextInt. Now first we need to test if the number is -1. So if the number is -1, we want to print out the sum and average, and then exit the program. So we can use an if statement here. So if the number is equal to -1, we can do our printf statements again. So I've got the sum is %d, and sum. Now, this will come up as 0 if we just run the program. We have still to initialize sum properly. And also, let's just put this in here. And it's going to be 0.2f average. Now this will begin as an error because I don't actually have an average method as of yet. For simplicity, we can just go in. Oops, that's not what I wanted to do. We can actually just go in and say that the, let's go for double, average is equal to the sum divided by the count. Now you'll notice that sum and count are both integers. So this will give me an error when I try to run the program. To fix this error before it happens, we just have to cast this count value to double. Now because we don't have the actual value of it here, we need to do a cast, and a cast is inside brackets, and we can just put double here. You'll learn more about those in future tutorials, but for now, that's just the way we can get it. So after we print out the average and the count, we then need to exit the program. And the system class has a method called exit, which takes a number, including the status. Now the status is 0 for normal execution, so we want this to exit normally, because that's what we wanted. You can also put the number 1 to say this is an abnormal execution, so in terms of an error happening, you could system.exit 1, 2, 3, there's some kind of conventions as to what numbers to put in there. But for now we're just going to put 0 because it's normal execution. Then we can put an else statement here. What happens if the number isn't negative 1? Now if the number isn't negative 1, we want to add this to the cumulative total. So we can add it to the sum. Now you can use the shorthand operator. Sum is plus equal to number. And also you need to increment the count because we've seen a new number. You need to keep track of the numbers. So that's it really. Now we've got the program looping round and looping round until every number has been read, and either the user has himself said, I want to stop the input, or type negative 1. So you have two options to stop the program. If the number is negative 1, the average is calculated, casted to double, and the sum and average is printed out and the system's exited. Otherwise, it continues on with the sum adding up the numbers and the count increasing the number so that the average is correct. So let's run that and see what happens. Put 6, 2, 7, 4, and then if we put negative 1, we'll see the sum is 19 and the average is 475. We have actually I forgot to put the terminators at the end, so there we go. Important thing to remember. And we can do that again with random amount of numbers. You can just stick in loads of numbers. Negative 1. So the sum was 76 and the average is 5.07. So we've just got rid of the kind of naive average because we don't really need it at the moment. So you go, that shows you that scanners are a useful thing to get input from the user. You'll see a little bit later that scanners can also be used to read from files and other things rather than just the console input. So hopefully scanners and loops are now clearer, and also control structures are also clearer. And in the next tutorial we'll start digging into the main part of these tutorials, and that's defining and using your own classes. Usually for people learning Java, this is just the next tutorial starts the good bit of the program in Java. This is all the kind of stuff that if you've learned a language before, it's the part you know. Apart from scanners, it's the part you know, it's the part that's the kind of boring part, and then in quotes, if you know what I mean. And for people that are learning new languages, it's learning a first language, it's the things that just fall into place. But it's now where it becomes, Java takes its own, it's object oriented, and it gets a lot more fun after this. So as always, feel free to leave any comments or suggestions or questions in the description below, not the description, in the comment box below. And any likes or subscribes are always greatly appreciated. So I'll see you in the next tutorial. Thanks a lot.